Hey, this is a Miss Albans physics video that will cover the difference between speed and velocity. First, we will need to know what speed is. Speed is defined as the distance covered per unit time. We typically talk about speed with cars. For example, we would say that in a car you could travel at a rate of 35 miles per hour, which literally means that you would travel a total of 35 miles if you were to continue at that speed for 1 hour. There are also different units that you can use to describe speed, such as 5 feet per second, which means that you would literally travel 5 feet in 1 second. Now, when you think of speed, you are probably thinking of instantaneous speed, which is the speed at a particular instance or point in time. This is what the speedometer reads in your car. It tells you exactly how fast you are traveling at that given moment. There's also something called average speed, which is the average pace someone or something would travel over a larger time interval. Average speed is often defined as the total distance covered over a larger given time interval. So if you were to travel 60 kilometers in 2 hours, your average speed would simply be the distance covered, 60 miles, divided by the total time, which is 2 hours, to give you an average speed of 30 kilometers an hour. So over this time interval, you could have stopped, sped up to 40 kilometers per hour, and then slowed down again for a passing car, and so forth. These would be your instantaneous speeds, but your average speed over the 2 hours would be 30 kilometers per hour. Now let's discuss velocity. So velocity is very similar to speed. It is simply speed, but it also includes a direction. So let's go back to our car example. The speed of the car would be 35 miles per hour, but in order to state the car's velocity, you would have to say which direction it is traveling in. So you could say the positive direction, or the negative direction, or even east and west, but a direction must be included if you're discussing a velocity. Sometimes to include the direction, people just simply put a positive or negative sign in front of the value of the speed. So for example, a velocity of negative 15 meters per second tells us that the car was traveling at a speed of 15 meters per second, but in the negative direction. Velocity is known as a vector quantity. A vector must include a magnitude, also known as a size, and a direction, whereas a scalar just has magnitude or size. Speed is an example of a scalar since it does not include direction. The equation for average velocity is delta x over delta t, and these deltas mean change in, and the bar over the v symbolizes that this is the average velocity that we're looking at. And delta x is also known as displacement, which is the change in position. We also have an equation for displacement, and it is literally the final position minus the initial position. So let's do an example. You are walking on a track and you want to find your speed and velocity. You start your timer when you cross the straightaway position. We're going to say the position is 0 meters, and you finish the straightaway, which your position would then be 100 meters, when your stopwatch reads 134 seconds. Alrighty, so first let's calculate the speed, which we know is the distance covered divided by the time. We know that we covered 100 meters in 134 seconds. When we divide this out, we know that we are traveling at a speed of 0.75 meters per second. So if we want to look at the velocity when we're traveling down the straightaway, we simply combine the speed, which was 0.75 meters per second, and the direction. We will just say that we are walking in the positive direction. You can as easily say that you are traveling in the negative direction if you wanted to. We will discuss this more later. Now, what would happen if you did one full lap at the same pace? Your speed would still be 0.75 meters per second, but your velocity isn't as simple. Remember that velocity is change in position over change in time, which is equal to delta x over delta t. And if you start and end at the same place, your final and initial positions are also the same. So your delta x value is going to be 0. If you start and end in the same place, you essentially did not travel anywhere in that time interval. Therefore, your average velocity would be 0.